Let us now have the derivation of ABCD parameters of long transmission lines. We have to recall that the line constants R, L, and C in short and medium transmission lines are lumped. Okay, that's why their ABCD parameters are approximate. But in long transmission lines, all of these R, L, C, and even G, if considered, or if it's even considered, no, are uniformly distributed. That's why their ABCD parameters are exact. No, when we deal with long transmission lines, we refer to the exact solution, okay, of those parameters in the long transmission line. Okay. Now, since we're going to show the derivation here, since these RLCs and all the parameters are uniform, that we have to get a section of circuit. Okay, and then this section, which has a length delta x, no, yun yung length niya, no, delta x, is x distance from the receiving end. Okay, that's our consideration. No? From the receiving end, x distance from it, we have a section of that transmission line which has a length that is delta x. Okay, now in this circuit, we just have to convert some parameters like let delta be d. Okay, so this in this case, for example, we will be treating this y delta x as y dx, something like that, no? Okay, kasi pag nag delta x pa tayo, magli-limits pa, so we can have the straight to the point na derivation, no? Okay, so we first have the KVL around this loop of the circuit. Okay, so the voltage here, all right, is simply, again, so i-convert natin yung delta x, no? So what we have is Vx, this one for Vx, plus dVx, so this one. Okay, so the voltage here is Vx plus dVx, and then let's have this voltage drop here, which is Z dx and Ix. Okay, and then the voltage here is Vx. Okay, so rearranging lang, and then when Vx is 0, we get this equation 1. Okay, next, by KCL, we get the KCL at this node. Okay, the current here is, again, yung delta x natin, papalitan natin, right, ng dx. Okay, so we have Ix plus I dx. Okay, so we have Ix dix. Okay, and then the current here, okay, is y delta x magiging y dx. Alright, times the voltage here. Okay, remember, this is admittance and this is voltage. That's the current. Okay, so we have Vx dVx. Alright, and then the current here is Ix. So we have Ix. Okay, so again, rearranging, and then when Ix is equal to 0, we'll get equation 2. Next thing to do is differentiate equation 1 and then substitute 2. Okay, so let's differentiate this. So we have the second order now, and then z dix. Okay, so and then we substitute this dix as yvx here, right? So we'll get this equation. Okay, now we have here a second order differential equation. And the solution for that DE is this one. Okay, so you now have A1 and A2 as your constants. And then your gamma is represented by square root of zy. Because we have here, zy. Yan. Okay, so this is the unit of this propagation constant is inverse meter. Okay, now let us differentiate this solution, okay, para makuha yung A1 and A2, right? Okay, so dvx dx is, and then yung gamma here, and then blah blah blah. Okay, now we have to recall equation 1. So punta tayo kay equation 1. Ano bang gagamitin natin? Equation 1 is Zix if we have dvx over dx, which happens to be the derivation nitong vx. Okay, so we replace that with Zix. Okay, now rearranging, we'll get this parameter as to be represented by ZC. Okay, recall we have the gamma here, square root of zy. Okay, so yung gamma here, zy, so lumabas yung ZC, which is square root of z over y. And this now, ZC is the characteristic impedance. The unit is ohms. Okay? Now, so we simplified now this Ix by injecting ZC here. Okay. Now, to get A1 and A2, we use the initial conditions when x is 0. Okay, so when x is 0, our Vx and Ix are respectively Vr and Ir. Okay, the receiving end voltage and receiving end current. Kasi nga, yung x natin is 0. Okay, now, let's recall equation 3 and equation 4. So, gamitin lang natin all those in order to get A1 and A2. Okay. I will be providing the copy of this material, so you can just simply browse and browse, no? So, balik-balikan nyo na lang in order to arrive at these equations 5 and 6, okay? Okay, so everything, equation 5 and 6 to 3 and 4, we will have what? Vx, okay? This entire thing, hindi kasha sa notes. And then also your Ix with this thing. Okay, so for Vx and Ix, we now see these things. Okay, and these are what? Hyperbolic functions. Okay, so let's go on. Vx now becomes cosine h gamma x sine h gamma x. Balik tayo, na? Vx. So, ito. Okay, so this is your cosine h gamma x and then times Vr. Okay, then your sine h gamma x is this one. The same thing for Ix. So this is your sine h, cosine h. Okay? So that, okay, we proceed when x now is the entire length. Kasi kanina, section x lang tayo, no? The entire length. Therefore, yung voltage natin here, alright, is now the sending end voltage. When x is now the entire length, your I here, we are considering now the current of the entire length, which is the sending end current. Okay, so therefore, so if this will be your, this is your Vs and Is. Okay? So let me just go back to my pointer. So now we have the ABCD parameters of the transmission line, the long transmission line to be specific. So we have AD, which is cosine H and cosine H, diba? So recall, diba, this is VS, this is A, VR, B, IR, then C, what is this? VR, ABC, D, IR, right? Okay, so, oops. So our AD here, so cosine, cosine H, okay? Our P, so is the entire ZZ, sine H. And our C is, ito. Okay, so 1 over ZC sine hyperbolic. Alright, so the unit remains the same, A and D, unitless, ohm and Siemens for B and C. Okay, but we have to take note that we are dealing with a complex quantity. Okay, and that your gamma, alright, okay, even though it's a square root of z, y, okay, complex quantity siya. Okay, so being that we have a sort of complicated solution for the long transmission line, specific no sa ABCD parameters, kasi inside the hyperbolic function there is this complex quantity. Okay, okay. Now, this is just your gamma. So, this is just the per unit. Alright? Per unit length. Okay? So, this kumbaga per meter dun sa mga L and C natin. No? That's why, to get the total, sort of, we have to multiply it with the line length. Okay? So, doing so, it's now dimensionless. Okay? So, your E gamma L will be, your gamma is quantity, complex quantity multiply to L. So, gagamitan lang natin ng mga properties wherein this and this is also equivalent to this. Yan, no? So, these are the things na pwede natin gamitin in order to evaluate the hyperbolic functions. Okay? We have two methods of evaluating them, no? So, we have like method 1, okay? Because it's complex quantity, so we cannot just simply input everything in our calculator and then equals, no? So, meron tayong konting evaluation na gagawin before we get to use our calculator, no? So, method 1. So, all the hyperbolic functions be evaluated using this. Okay? So, pwedeng, what I did was, this E function here will be like treated with this. Okay, so we have factored out 1/2, and then ito will be using this. Alright, and also this one and this one. So just take note of the negative, ha, kasi negative ito. Okay, so for our sine H, the hyperbolic sine function, again, this one will be treated like this to evaluate, and then ito na siya. So again, since we have negative here, negative to, minus, minus. Don't forget. And cosine is plus, sine is minus. Okay? Something like that. Now, method 2 will simply be remember the property nung cosine angle of cosines, two angles, right? The cosine of two angles Okay? So, remember yung ating, your omega, not omega, gamma L is also, this times L. Okay? So, therefore, we have two angles here. So, cosine H gamma L can be represented by this. We have two angles. So, what can we have is the cos, sin property. Okay, identity of cosine. Diba? Okay. So, cosine of this and then ito yon, and then cosine of this. Okay? Okay? Tapos cos, sin. So, sin of this, and then sin of this. Okay? Cos, sin. Cos, yun na. Something like that. Okay? Now, for sin H, so, simply, sin, cos, sin. Okay? Sin H of this, and then this one. And then next is cosine of this, and then sine of this. Okay? But we have to take note that our beta L is in radians. That complicates the solution, no? Kasi naka-radian siya. So, once na you use the wrong mode in your calculator, then everything is all wrong. Okay? Okay, so that's for the derivation of the ABCD parameters. Okay, so again, as a recap, so these are now your ABCD parameters. Wala naman nagbago in terms of the matrix. VS is equal to AVR plus BIR, etc. No? So, ganun pa rin. It's just a matter of the unique ABCD parameters of each transmission lines. Now, in the case of long transmission lines, we have hyperbolic functions for their parameters. Okay?